Okay. Well, what's the next thing we have to do? We're given that the find the average flow rate, right? Flow rate, right, per unit of radius. I believe that's the statement. Okay? Well, what is that?
How fast it's going.
Well, it tells you in the sentence. The next thing in the sentence says that's equal to what?
R equals 2 millimeters.
What now?
R equals 2 millimeters.
Okay, well, we can do that for R equals 2 millimeters, but if you read the paragraph, it says rate at which blood flows per unit of radius at distance R from the center is equal to what?
Equal to the speed of the distance multiplied by the circumference of the circle at radius R.
I think you read it. I couldn't understand it, but, okay. Now there are more words, but it's equal to speed times circumference, right? Okay? So at R equals 2 centimeters, what can you tell me? Well, we calculated the speed here. I mean, we need the speed and the circumference, right? So the speed is 4.8 millimeters per second, and the circumference is what?
The circumference is the whole thing?
Well, circumference means, it says the circumference at that radius, circumference of a circle, let's see, of a circle of radius R, right? And that would be the average flow rate per unit of radius at radius R. So it gets complex. I mean, this is a fairly complex question, you know, not from an advanced perspective, but from, you know, the position of a good applied calculus student. This is fairly complex. It's as complex as most things you've probably ever had to think about, okay? I mean, as far as the reading level, the idea itself is somewhat complex, okay? So you have to sort through it. Okay, well, the circumference is what? This is at radius R, right? The circumference of a circle of radius R is 2 pi R, right? Okay? And that's then 2 pi times 2 millimeters. Now it's important to remind ourselves that this is a rate per unit of radius. Well, it's the product of this and this. So that's going to be what? This is going to be 4 pi millimeters multiplied by 4.8 millimeters per second. I believe it gives you 19.2. millimeters squared per second. Okay? Make sense? Well, calculate the other one for R equals 3 and see what you get.